Welcome to class 12 already. Hard to believe. So tonight we're going to talk about natural language processing for security. This is the reverse of what we've been doing. We've been getting rid of labels, we've been encoding things. We haven't really paid much attention to text, and we want to talk about that a little bit tonight. The obligatory housekeeping slide, we can just move past that. Tonight, here we are, class 12. Got some good feedback from somebody in the class today that we should put dates on this instead of just a nebulous number. I will do that. So thank you for that feedback. I think that was good. So let's, tonight, our class builds on machine learning fundamentals and data preprocessing. And then we'll talk a little bit about feature engineering as well with respect to NLP, which is natural language processing. Assignments. Tonight, I've already posted this in chat, and I'll make sure that it gets up on Google Classroom as well. We have the last assignment before the capstone. I also posted the capstone. There's some differences in the points. Don't worry about that. I'll get that all straightened out. But the TLDR is that capstone. I think it says in the doc it's worth 50 points. It's only worth 30 points. So that's my bad for not checking. But anyways, don't worry too much about points. Okay. So tonight, by the end of the class, we can talk about the basics of natural language processing, NLP, talk about some text pre-processing, sentiment analysis and topic modeling. Tutu, if you're out there, we can talk about Hugging Face a little bit towards the end. Hugging Face isn't a thing, it's more of a community, but there's a lot of AI models and stuff up there. I didn't want to muddy the waters by going there, but you know, that might be a fun place to look around. We'll talk about that some more. Okay, so what is NLP? Natural language processing. It's like teaching a computer to read and understand human language the way we do. So if you show a sample of a phishing email and ask a student and ask what makes it suspicious to humans versus machines, that's the kind of stuff we're going to be talking. So humans can understand context, they can understand sarcasm, intent, sentiment, right? Machines only see characters and words. They don't get the context, which is why AI is never going to replace us until it does. So why NLP for security? If you look at a firewall entry, right, what story does it tell you? What is that? What does that log mean? It means something to you, but it probably doesn't mean a lot to a machine learning algorithm. So think about what kind of text data you encounter every day, right? You see email, you see security alerts, you get vulnerability reports, incident tickets. And if, you know, I've sort of alluded to this, right? What you're looking for are things that are different, right? If you are a tier one analyst and you process a whole bunch of false positives, but occasionally you get a true positive, what makes that different? And I think that's what we're trying to figure out here, right? So much like we use algorithms and data to find anomalies when we're doing machine learning, NLP finds those same sort of things in text data, right? So, you know, you can generate terabytes of logs every day. Those logs all have useful text context, command lines, and that kind of stuff. But if you're just focused on sheer anomaly detection, you ignore some of it because that is important context to figure out what is going on, right? Oh, I found an anomaly. What's going on? Is it a compromise? Is it lateral movement? These are the kind of questions that we're going to try and answer, right? So if you look at ambiguous text, if you saw something that said the admin accessed the server, right? Is that always suspicious, right? What context do you need? When did that occur? Um, is that unusual for an admin to access that server? And is it a critical server? Is it a less critical server? How did they access it? Is it a remote desktop? That those kinds of questions are all important, right? So that's why NLP is hard, because it's all about context. So what do we want to do? What's NLP do for us, right? Um, you can convert unstructured data to structured data. And we'll talk about mechanisms to do this. So you could say it if you see a log entry that says a critical vulnerability found in Apache Log4j affecting remote code execution, that's a lot of stuff. But if you process that using NLP techniques, you could say severity critical, software Apache Log4j, vulnerability type RCE, CVE, right? And give the number, right? That's all super important. This is how we broke things down when we did postmortems at Google, right? Is it was very um, functional, right? So you could sort on. Andrew, you have a question?
Hey, yeah, real quick, just to understand, is MLP like based off of structured data, like ML pipelines, or is it something that's sideways, like like a third thing?
It's a pipeline, but it's different, and we'll talk about that.
Super cool. Thanks, sir.
Yeah, you bet. Um, so you can identify key entities. This is important when you're doing threat hunting, right? So a threat report might say APT 29 used Cobalt Strike to target healthcare organizations. And after we process it through NLP, we have a threat actor, APT 29, a tool, Cobalt Strike, a target structure, healthcare, right? So this helps us contextualize what's going on and see if other things that are similar to this are happening, right? So you can automate analysis. What if you have 1,000 security incident reports that need classification? How do you do that, right? Because they're all different. Do you spend 50 hours going through them? I've done that work before. NLP, maybe you can do it in 30 minutes. I don't know if you have a pipeline, but that's what the objective here, right? Faster incident response, improved correlation with like threat intelligence, um, proactively managing vulnerabilities. How much natural language is there in a vulnerability report? Like everything is just a bunch of text, right? We'll look at some examples, right? Enhanced situational awareness. So this is all the kind of stuff, right? If you're just looking at machine learning, you might have an anomaly, but what's the context around that anomaly? I have an anomalous process that is running and it's communicating with a command and control known IP address. How did that start? Maybe if I go find a command line and see that, maybe I got Mimikatz running. I have was it 4688 is the process start, those kinds of things, right? How did that process start? Was it started automatically? Is it command line? That's where you get super good context um, from text data, right? That was always a trick that we would use when we were hunting when I was working on the blue team at Microsoft, right? Text is always uh, a fertile source of information. Okay, so let's talk about text pre-processing. Um, This is like if you were going to cook something and not wash your vegetables, right? You got to clean them and prepare them before you're cooking. Sorry, it's dinner time. I'm stuck on food, right? And what the thing is, right, that you want to change raw logs, which can be variable, right, into cleaned and tokenized logs. And we'll talk about this a little bit more. So for instance, you know, for raw text, you might have something like alert. Here, I'll show you. Right. Alert, malware detected on server 01. User John Doe, company com may be infected. Right. Action required immediately. But after you pre-process it, right, we see we've got alert, malware, detected, server, user, right? So we've sort of changed how we're looking at these things. So the key step is, right, tokenization. Think about this: is you're breaking the sentence into word. This is like regex or something like that, super regex. Stop word removal, right? Let's talk about stop words. This and is words that don't end any meaning, but they help string a sentence together. Machine learning doesn't care about sentences, right? We care about what the content is. We'll talk about this some more, but stemming and lemmatization, right? Which is where we're grouping things, right? Running, ran, turns, runs, right? All those three things end up as run. So they're all kind of the same basic thing. So we're going to change all those different variations into one thing. And we'll see an example of this a little bit later, right? And then text representation, right? We convert words to numbers, machines understand. And this is all part of the pre-processing cycle. So, you know, for instance, if you got a phishing email, how would you tokenize it, right? How, you know, you'd remove the stop words. And then you could go on from there, right? You could group the words, right? You can change them into like a single word, right? Run is the same as running, ran, runs for all intents and purposes, right? And then, you know, how do you represent the text? Okay. So let's talk about this a little bit more. Let's dive a little bit deeper, right? Tokenization. For instance, let's say that we had the original text is CVE 2021, right? Could you imagine this is something you would probably see in your, you know, your vulnerability management system, right? And after tokenizing it, right, we see we've got a CVE, we say it affects log4j, and then we have the file name. So that's an example of tokenization. And we can remove the stop words, right? Uh, should you remove not? I mean, this is where context is important, right? Is if from security, if you remove not, do you know that you suddenly have something that's not malicious that is malicious? And then, you know, you need to think about custom stop words. Uh, you know, do you need to have TCP and everything, UDP, that kind of stuff? So as you're thinking about stop word removal, what are those stop words that may not be in the dictionary that you need to remove, right? So think about those kinds of things. You can do statistical analysis. Um, so we looked at that sample security alert, right? And then we talked about what that meant when we tokenized it and removed stop words. And that is very important when we're talking about tokenization. So if you look at the examples here, these are from a notebook that I put together, and some of this is in the case study that we have a student notebook we'll go through. But this is the kind of output that you get when you are doing this process, right? So if you look at the the words on the side, right? Those have been tokenized, right? So, and they've removed stop words. Otherwise, if you don't go through this process, your word cloud and your top terms would be full of, you know, stop words and things like that. That's why we do it. Okay. So what are the basics of NLP security? We talked about these. I threw these words out there before. Stemming is kind of what we saw before, right? It chops off suffixes, right? Running goes to run, detection goes to detect. You may end up with some non-dictionary words, but that's just how it goes. Lemmatization uses a vocabulary analysis, and this is like nerdy stuff. The dictionary base form is called a lemma of a word. So better, good, right, ran, to run. So that's basically what lemmatization is. So now you can excel at Trivial Pursuit if anybody plays. So it's more accurate, but it is computationally intensive, right? So if you look at like a real example of this, so sorry, I couldn't come up with anything better. The attacker was attacking the attacked server, right? And if you stem it, right, you've got attack, 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 and then after lemmatization, you got a different set of things, right? So basically what this is doing is it is making it easier for you to compare one entry to another. And that is important because it makes it easier for you to do analysis afterwards. And if you do like postmortems and things like that and try to do root cause analysis, this is super useful. Okay, text representation. This is called TF-IDF. Term frequency and inverse document frequency for those of you playing along at home, right? And term frequency is how often a word appears in a document, right? So if you look at a word cloud, we've seen a couple of those. The larger the text is in a word cloud means the more frequently it appears. And same thing with like TF-IDF graph that we looked at. The longer the bar, the more frequently it appears. So, and then IDF is how rare a word is. So that's the inverse of term frequency. And that's the, like malware appears in a lot of security documents. So it has a low IDF. And then something more specific like APT29 appears rarely. So that would have a higher IDF. And that's calculated by that NLP algorithm. So the result is common words get low score, rare words get high score, and this identifies unique indicators of threats, also known as outliers, right? So why is this important, right? We can convert a text to a numerical vector. Frequency is certainly a value we can use to weight it. This helps us with similarity, right? If you're doing analysis, how close is one thing to another, right? Stemming and lemmatization can tell you that. And that feeds into the classification algorithms. Okay. So let's talk about sentiment analysis. So this is something that you can't really analyze sentiment if you're doing straight up machine learning, right? Because you strip all the context away with respect to how a thing happened, and you're just looking at the thing, right? So, what sentiment analysis does is the TLDR is it determines an emotional tone. Is it top, positive, negative, or neutral? And if you think about it through a security lens, it's not necessarily the emotional tone, but you have to think about it in the context of a threat level, urgency, confidence. OMG, all my files are not accessible anymore. What do I do? Along with some other potential indicators, you tie those things together, and it's like, oh, darn, I have ransomware, or somebody has ransomware, hopefully not. So you could look at it this way, right? As far as for applications. So you could look at like employee morale for insider threat detector detection, you know, looking for indicators of compromise, right? With respect to the things you see in internal communications. You know, you could see someone who's excited about product launch. You could see something that's negative about I'm not valued here. Um, Concerning, right? They're going to regret not promoting me. I know where all the passwords are, or all the documents showing the CEO's salary, or what have you, right? So, but the big concern there is privacy and consent and false positives, right? You don't want to be the central scrutinizer having to wade through these kinds of things. But should you look at them? You know, it depends, right? You could analyze a phishing campaign. Um, you know, if your password needs to be changed or you'll lose access to corporate email, those kinds of things. So you know, you have fear. It's like, oh, you've been breached. You need to reset your password. CEO requires action, right? Those are you know, phishing uses negative sentiment and urgency to try and spur people to action. This is important. This happens all the time. Social media monitoring, dark web. Um, you know, somebody has weak security or there's a vulnerability or they've deployed incorrectly. We found their customer database in an open AWS bucket, that kind of stuff. Um, Brand reputation. What's the public reaction to a security breach at my company? uh, Brand reputation, right? Sentiment tracking. How are we doing after a breach, right? What's the public sentiment? Uh, you know, can you manage crisis communication? So there's a bunch of context, right, that you need to be cognizant of, and NLP can help you with that. Okay, so let's talk about another thing, topic modeling. This is kind of like PCA, primary component analysis, except it's with text. So it's like organizing books into categories or anything into categories without reading every page or knowing everything about it. And we do this as humans because we have the ability to recognize patterns quickly. And that and opposable thumbs and the ability to jog, not run, I think, are why we're at the top of the heap, allegedly. And what happens is the algorithm finds patterns of word usage across documents, right? Um, you know, this is like DLP systems do this kind of thing, right? I'm going to categorize this document, and if somebody moves it to their Dropbox, then I'm going to generate a security alert because they're exfiltrating data. So you analyze how often a word occurs, right? You group words together that frequently appear together, and then you assign top categories, and you provide probability scores for each assignment, right? So so we'll look at some topics here in a little bit, but basically it's a combination of words. Let's see, I can show you this quickly. So we have some topics here. If you look down, right, we're topic modeling, and these are the topics down here. If you look at them, right, topic 0, we're topic modeling with 8, and these are related. We've got a view kind of what they're related by. One of these, uh, so here you go, right? This, so look at this. If you got this, sorry, but if you look at this, you can see what the topic is composed of, and you can see the effect of stemming, right? And lemmatization, right? I think you lemmatize before you stem, but you can see that it's window, not windows. It's EX instead of what, who knows what, EXE. But that's kind of what that looks like. And what this does is the topic relates these words together by how frequently they appear close together, right? So it's the co-occurrence of these words, and that's how the algorithms build topics. All right. So if you if we want to dive a little deeper into it, you could think about it this way, like threat intelligence reports. If you got 1,000 reports, you could look at that and figure out what are the topics, right? What are the things that occur close together, right? Maybe ransomware has encrypt payment and Bitcoin all close together. Vulnerabilities have CVE, patch, and exploit. If you look at incident grouping, if you have 500 security incidents, right? 200 have topics that are related to email attachment credential, which is phishing, or 100 have USB malware endpoint, right? So you're able to see what words occur close together and relate those back to incidents. So there's a bunch of different things that you can do with that. So if you look at the charts here, right, you got the word frequency chart, and that shows the most important words per topic, just like I showed you, right? You've got the topic number and the name. Pie chart, right? That's document distribution across topics. And then, again, topics are things that are grouped together. And what you can say is, what do these topics apply to, right? If I say a topic may be an indicator of malware, how many emails does that apply to? How many files does that apply to? And that helps you divide things up. All right. So let's talk about this case study. And this is the notebook I put together. And basically what we're doing is this, is we're going through the process of doing NLP analysis. So this again is synthetic data, so everything is going to be perfect. But what we're doing is we're doing our imports. Here's our problem, right? Is that our, oh darn, sorry about that. I broke kernel. Sorry, guys. I did an update to Mac OS and had a couple of crashes since then. So where were we before we were so rudely interrupted, right? We talked about the problem definition. I wonder if it's when I try and okay, we're back. So the problem definition is that we get thousands of text-based alerts, and that takes a lot of time. We want to classify incidents, extract entities, do sentiment analysis, discover hidden topics, and reduce our analyst workload. So how well do we classify? And you guys can follow along if you want, right? And then how well did we do, right? So we generate some synthetic data. We do some exploratory data analysis. That tells us what the incident types are. And then we have a nice visualization, right? So we're doing some email classification, and we're looking at incident text at the length distribution. And now we're going to do some text preprocessing. You can see here that we've got security stop words that we're going to pull out. It tells us what the stemmer and the lematizer is, which is an awesome word. And then we pull the stop words out. And once we're done with that, this tells us what we're doing. And again, you guys can look at this after class if you want. But basically, we're setting everything to lowercase. We're removing characters, tokenizing, removing stop words, stemming, and then we've pre-processed all the data. And then that shows you the length reduction. So now what we're going to do is we're looking at the TF-IDF features for incident classification, right? Phishing, we see that network malware and vulnerability are high. This tells us what the features are across all the incidents. So you can see it's like, oh, looks like email, but maybe when we get to topics, we'll think about this differently. But that is the average score. So now we're going to do some sentiment analysis. This is important. So I hate jumping back and forth, but I'm going to do it. Is, you can see the kind of the sentiment in the email type and the subjectivity, right? And the security urgency. But if you had a different view, so this demo is an actual JSON file. It was a staged attack, but this analyzer went through and it does something a little bit more interesting than email, because what it's doing is it's looking at the actual log data and it's scoring it, and it's telling me, what are the biggest events, process start, that's the biggest one. Who is the top user? This guy, P. Gustavo. Maybe I need to look at that on WEX server. But this is kind of cool because it is pulling an Elastic ECS file. You could do anything. You could tell it to go get connect to Splunk and do that kind of stuff. But this is a real example of kind of what this looks like. We've got the top 10 malicious keywords, and this is all a one-day event, so there's not history, but this gives you a good idea of kind of where we're at, right? We've got 100,000 records, 25,000 threats, of course, because it is a demo, but we want to be able to show, right? So we do the same kind of thing here. Text analysis, right? Top terms, topic modeling. Here's the topics and their composition. And you can see that the stemming and lemmatization has been done here. This does anomaly detection. Again, we're using isolation forest, and we're familiar with that. And this gives us this output here, right? So this is kind of cool because now we have our top 15 terms. We have the topic modeling results. What is the most frequent topic? We have a word cloud, right? What are the most prevalent words? You can see that here. Command line topics, I think this is broke, but I didn't spend a lot of time looking at it because I know there are command line things, and we'll show that here in a minute. Content length, what's the difference, right? And then we get to the point where we have the top words in each topic. So the cool thing about this, right, is we have this word cloud of security threats, that these are the security words, and you can see it's like, oh, geez, Mimikatz, I hate that. Invoke Mimikatz is the highest prevalent security term here. So something's going on, and I want to know what it is. And then the rest of this should somewhat familiar, right? This is all the stuff that we've been working on so far. And you can see right here, we've done anomaly detection, right? We have a threshold, we see what percentage are anomalies, top event IDs, anomalies over time. Again, this is like a short-term thing, so you don't have a good long-term view of it. And this gives you a summary of anomalies. So again, we're doing this with the text. We're not doing it with the data that's in there, but you can see we get the same kind of results, right? And we have a log analysis dashboard, shows you the normal and anomaly percentage that are detected. Again, I didn't do ground truth because I was lazy, but we could probably go back and do that if we wanted to, and showing you risk distribution. And all this is well and good, but I just wanted to show you, a real example of what this looks like using actual data, right? These are actual topics from the log data. It's not synthetic data, and you can see how this looks. All right. So, Andrew, yes?
Real quick, in your experience, like, did you set these systems up to be monitoring tools or reporting tools? Does that make sense? So, like, did you directly connect into, for example, like a Splunk API and have them consistently looking in, like, producing updated results on, you know what I mean, a time frame, hourly, something like that, like real time, near real time? Or did you just like, how's that work? Does that
Yep.
make sense?
So there is a progression. And it goes basically from everybody sits down and you kind of kick some ideas around and you say, well, I'm going to go and I'm going to do an investigation. So you use these same sort of techniques and you do an investigation and see if you can confirm your hypothesis or if you need to adjust it. And then from there, you come up with a proof of concept, right? And you test the proof of concept. And if it works, right, if you're getting good results or you can tune it to get decent results, then you'll actually move it into production into a pipeline. So there's back in the bad old days where we had AI, right? You needed to wrangle up a data scientist and a Python programmer or some sort of developer to help you do this stuff. If you're fairly competent at it, you could do a little bit of it yourself with R and whatever. But the beauty of this now is that you can do everything up through the proof of concept kind of by yourself. And that's where you need to start working with DevOps to move it into production. However, right, with things like Claude Code, you can make something that's fully deployable if you prove it out. I was messing around with one of our malware detectors just to see what I could do, and I ended up with a deployable Docker container that had my model in it and everything else, and ran a dashboard. It was pretty cool. So you can get pretty far, but at some point it's going to have to scale. And that's where you have to think about, okay, maybe I don't do it with the stuff I got in scikit-learn. I have to use, Apache Spark, Spark ML, something like that, that has the ability to process at a high rate of speed. And those are all things that are, you could probably talk to an LLM about them, but you probably want to bring your DevOps into it.
100% cool. I just wanted to make sure that I was thinking correctly. I'm already thinking about scaling, but that's perfect. Thank you, sir.
All right, yeah, you bet. Okay. So
See,
so
I have
then
one question.
yeah.
On the prior set of visualizations you had by topic areas, were those topic areas, those were auto-generated? Like, it doesn't know what to call it, but it's just calling it like topic 0 through 7?
Yeah. So that's a great question, right? The topic doesn't have a name, but it is the association of these words to each other, right? How close they are. And that's what generates the topic. So the NLP algorithm, NLTK, I think, is the natural language toolkit, I think, is the library. But NLTK does this for you, right? So that's the magic that goes in, and you set the number of topics. So you can that's a hyperparameter that you configure, are the number of topics that you want. So it doesn't tell you how many topics, but it's a lot like things we do with contamination in NU, where we're guessing a percentage. That's the same thing when you say how many topics do you need. I think there is some analysis, I can't remember, that finds you an optimal number of topics. I'll have to go and look for that. But it's similar to like finding K, right, with silhouette and elbow. And it may even use those, I don't remember. But the TLDR is that it's basically you take a swag and say I want 8 topics. I think 8 is the recommended number, and then it spits it. Sorry. Did I answer your question?
Yes, it does. Thanks.
All right, cool. Okay. So we did some sentiment analysis, and here's an example, and you guys can look through these. And these are some obvious, low-hanging fruit for synthetic data. But you'd be surprised how many times people click on stuff like this. And we're talking about topics. So this code does topic modeling, and we set the topics at 5, I think. I don't remember where. It's up in here somewhere. But anyway, so it spits out 5 topics. There might be more. You could tell it to do 10, and it would keep looking for those relationships. And then it's doing an analysis, right? What are these topics? Where do they appear in threat intel? So here's an example where you could do correlation. Is if you know what these terms are and how close they are together in your threat intelligence, and you match them up with stuff in your data, you might be able to find an APT or something like that. It's very similar to doing correlation with IP addresses and that kind of stuff. Same kind of concept. And and here's how our topics are distributed in threat intel. Again, synthetic data, so of course it looks nice. And then it gives us a probability of a dominant topic based on the number of documents. So that's an example, right, of where topics come in handy, right? Is you could have topics from threat intel, and you could have topics from your logs, and where do those 2 things connect together? So there would be an example, right? So then we do classification model training, right? And what this does is it spits out incident types, and again, using logistic regression, we've seen that before. Naive Bayes, not so much, but it's a linear algorithm similar to logistic regression. And it tells us the best model is logistic, of course, 100%, because it's synthetic data. And then it gives us confusion matrix. And this is basically how do I find vulnerabilities, malware, network phishing, those types of things. Same sort of stuff that we've been talking about. All right. And then last but not least, right, task 2, we can classify emails, legitimate or phishing, kind of by looking at the contents of the words, right? This is something that happens all the time, automatically, right? Looking for a certain number of terms, classifying it for us. And then, last but not least, we're going to evaluate our model and interpret it. And this tells us how it performs, what it did, what it found. And then we got some stuff here like business impact and insights. But y'all can. All right. So that's kind of how. Sorry, I'm going to start my presenter view again. Okay. So that was our case study for how NLP would work in a SOC, right? That you can come in, you can look at incidents, you can look at the text of that related to threat intel, You could look at email, you can get sentiment analysis, all these things. And that's all text based, right? That is context that is useful to us as we do our jobs. And you can, that's how you pull out IOCs. You can search wantonly through the data, or you can train an algorithm to do it for you. Enhances threat hunting, right? So there's a bunch of benefits to being able to do this. Again, my experience, it's always a combination of the two. The example in the that I gave of Mimikatz, that's real. I mean, that kind of stuff happens. PowerShell commands, all those sorts of things. All that is great context. If you look at Microsoft logs, let me see what we got. This is actually the logs that we did the NLP analysis on. These are the threats that came out of it, right? It tells you the content of the script block. So that the demo that I put together does this. It goes through and it pulls out the event ID, the computer, the user, what the warning is, like PowerShell. This should be higher in a warning because it's Mimikatz. But these are all things that you're able to do with this. Duraj, you got a question?
You did mention about the script block. Was the model able to decode a base64 encoded PowerShell command?
I don't believe that it would recognize encoded PowerShell. But the interesting thing about encoded PowerShell is it's easy to decode if you know what it is. I mean, that's the purpose of it, right? So you could decode the PowerShell and see what it's doing. To me, encoded PowerShell is always a red flag. I know that some admins use it because it makes scripts run more reliably, but that is certainly a trick that adversaries use as well, is encoded PowerShell, so you can't do the word processing. But it's all encoded the same. I can't remember the details, but it's trivial to decode because obviously the system has to do it. So you can break that out. We've done that in the past where we would decode the PowerShell. So basically, I'm interested if it's encoded. I decode it and I see if there's any. I can use the NLP techniques on it after it's decoded to see if there's anything that is threat-worthy. But that's a good question.
Okay, so we do need to provide a decoded file to the NLP in order for it to categorize.
Yeah, and that's,
Okay.
usually you'll see if you're doing command line capture, which I encourage, it sticks out like a sore thumb because it's infrequent where you see encoded PowerShell. So it's not that heavy a lift to do the decode. And you could probably ask your Python code to do that for you, right? If it's encoded. I think there's something in the example about encoded PowerShell. I don't.
Unless it's like really, it's decoded and decoded using like gzip compression or something, that becomes tedious then.
Yeah, but I think just straight up encoded PowerShell on command line. I think there's a common encode decode for it, and I don't remember the exact mechanism, but it's basically it's all reversible. It's not like encoded
Yep.
with a private key or anything. So you can avail yourself of that mechanism, and because of the fact that it's infrequent and interesting, it isn't that much of a burden really to do. But when you do log analysis and you find encoded PowerShell, you should decode it and see what it's going.
Yep. Thank you, Professor.
All right, yeah, you bet. Okay. All right. So let's talk about benefits of NLP, right? You get automated insights, right? You can do it at a higher speed than an analyst can. You can find patterns that people might miss, right? Analyst fatigue. Who's got time to look through a bunch of logs, right? If you've ever done hunting and actually look through logs, you can only look at so many before you have to go up and take a walk because it, really is tedious, right? And you lose focus. Algorithms don't do that. And you can do correlation, right? Those patterns are the same in threat intel as they are maybe in your logs. So if you have done some NLP analysis of threat intel, you can do that correlation and find those patterns, right? The topics should be similar, I would guess, right? If you look at it from that perspective, right? My topics in threat intel, if a topic matches from threat intel to log data, I would want to correlate those two things together. So you can proactively threat hunt, identify trends, maybe you find new areas that you want to hunt. I've seen this actually happen in practice, right? Where you see a pattern emerge from the text data, and it's super helpful in that respect. Context, right? You get better background without doing a bunch of manual research if you can do that automatic correlation. I think that's one of the biggest weaknesses of threat intel with respect to its applicability to security data is if you don't correlate the two things, you're not getting a lot of value from it because who can remember what's in a threat report? It needs to be available at time of use to the analyst for it to achieve its maximum value. Scalability, right? Obviously, if you have 10 incidents a day, you can go through or not 10 incidents a day even, right? But you could, if you have a low number of incidents, you can go through and you can actually look at the logs maybe. You can do the swivel chair thing and it's going to work. But as you scale, I've worked at all the big cloud providers and scale is daunting, right? There's no way that humans can keep up with it. That's what our adversaries are counting on is the fact that we can't keep up with it and we do get tired and we do have fatigue. So they're banking on it and we need to take measures to make sure that we're being effective in doing our jobs. You can avoid cost, you can gain efficiency and gain speed by employing these techniques. And, we want to get people out of the swivel chair. We want to automate this stuff so people can do things that need people to do. So what are some of the challenges? The model might classify something wrong, right? What's the difference between there's a bomb in your broom closet or there's a logic bomb, right? Two completely different things that might end up grouped together or might get flagged if you aren't careful. So context matters, right? And you have to have a security specific training data and models to make it work, right? Some of the general models may not. Data quality, right? You have issues with noise, logs with mixed formats. I think I've said this before. We tried to take all the security log things and put them in one database. So we wanted asset information, we wanted stuff from OSQuery, we wanted stuff from CrowdStrike, we wanted all that stuff in one place so we could analyze it. And we ended up with a curse of dimensionality because we had 2,300 rows or something. So we had to go do something different. And you know, there's always missing logs, missing context. If you've done response and log analysis, there's always, it's like, why did this system not send me logs, or why is there garbage or gibberish in it, or the time is wrong? I mean, there's always something, right? So you got to worry about that. So you need to make sure you got robust pre-processing pipelines, right? That you get good data put through. You know, how do you deal with ambiguity and sarcasm, right? It's hard enough to deal with that as a person. And you know, kill the process. What does that mean? Is that a legitimate IT term, or is that a threat? You know, different teams use different terminology. If you have a follow the sun model, you have cultural influence on the terminology that is used across all your teams. So think about that kind of stuff. You have adversarial text. We'll talk about adversarial AI, but this is an old one, right? Elite hacksaws, right? You know, using elite speak. If you're looking for patterns or regex, you know, maybe that evades it. Base 64 encoding, that's what the encoding is for encoded PowerShells, base 64. So you can reverse that, right? Steganography, there's all kinds of different things. And it's an arms race because attackers are going to adapt. Privacy concerns, right? Command line data almost always has personal information in it. Might have customer data, so you need to be considerate of that. Sometimes it's scrubbed depending on the pipeline. You know, you need to think about that, right? If you're getting scrubbed data as an analyst, somewhere upstream, someone should be doing analysis of what is scrubbed to make sure that it does not contain security relevant content. You know, you've got GDPR, HIPAA. Was an interesting brief from our legal team regarding this when I was at Google. And they basically said that we have to collect enough information to run our service. Our terms in EULA cover that. So the user should expect that we collect a certain amount of this information that we'll use internally, but we won't necessarily divulge it to anybody else except maybe law enforcement. So, you know, that there's no free lunch there. And then, you know, ethical use of it, right? You don't want that stuff to end up getting dispersed widely for a number of different reasons. And it needs to be limited in purpose, right? This is always a problem in security because everybody thinks that they need access to all the data. And that isn't necessarily true. So you've got to think that through, but I think that's a whole nother topic. So, you know, it's resource intensive because of the computational cost. You can take time to train, right? You don't get results immediately. It's like any other model. You have to train it over time. You know, business changes, the rhythm of the business. What does the shape of that look like? It's even harder with NLP because it's text and you have to continuously train it. So it's not just something, it's not a one and done kind of thing. So how do you do that, right? Explainability and interpretability, right? Can you explain the model and can somebody interpret it? So start simple. Make sure you have good training data. There's a bunch of sources for that, right? Again, why can't they get rid of you? Because you're the human in the loop. Somebody's got to make sure that all this AI is operating correctly. So they're going to need an AI wrangler for that. And you need to regularly evaluate the model and make sure that it's getting retrained. Okay. All right. So key takeaways for this segment, right, is you need NLP, right? There's no way humans can analyze all this data. And the volume problem is only getting worse. We got more logs, we got more emails, and it's a torrent, right? It's ridiculous how much stuff we have to look at. And then, think about it, right? How much text in your day job do you work with if you're an analyst? How many emails and screens and websites and threat reports and all that other stuff do you go through every day, right? Your brain hurts at the end of the day because you have tried to intake so much information, and you're the meatware that is making all this stuff happen, right? You gotta try and automate that to some extent to reduce your workload. Make sure you pre-process, because if you looked at those examples, right, with the stop words taken out and with stemming and lemmatization, it increases the commonality, it lets you do topics, and that's how you do the analysis. It's like the principal component analysis. What we're doing is we're trying to reduce dimensionality in something that has infinite dimensions because it's human language. Sentiment analysis, emotional tone matters, right? Logic bomb versus I'm going to set off the bomb are two different things. So you have to think about how that works, right? That applies to insider threats, phishing, brand monitoring, but you need to make sure you understand the sentiment. There is functionality in some of these algorithms where you can do sentiment. Topic modeling, right? We talked about that. That's like PCA. PCA tells how the numbers relate together. Topic modeling tells you how the words relate together. Campaign detection, how do you group related security incidents together? If it's a similar approach and they have a consistent command line, you can help narrow things down much more quickly, group things together. And then, how much text do you see in the day in the life of a SOC, right? You're getting an alert, you're getting an email, you got to read it, right? What if there's a way to make that better? Think about vulnerability management or software scanning. Those reports are full of text that doesn't really tell us anything interesting, right? So maybe if we apply some NLP techniques to those, we can, reduce our workload some. And that's going to amplify your ability as an analyst. And also that is a superpower for your capabilities, because you can do this kind of analysis now. And strategically, right, that helps you be more proactive. All right. So, let's talk about next steps. Tutu asked about Hugging Face. Hugging Face is actually, it's a community. It's like GitHub for algorithms, if I can get it up here, sorry. And it's pretty cool. I encourage you to go look at this. I've held off on mentioning it because you can really go down a rabbit hole here. The only thing that I would say to anyone is these are some of these models, like the models that you guys create in your code. I'm guessing there's a lot of people here that are data scientists, but there's a lot of people that probably aren't. So make sure that you read the manual, I guess. There should be there's text that's associated with these, but there is a lot of cool stuff up here. You could spend the rest of your life up here finding all kinds of cool things, but this is like scikit-learn on steroids. Well, I mean, they have models just for scikit-learn, and that's kind of the cool thing. But there's a boatload of stuff up here. You can just go look for different models for just about anything that you could want, but this is a great place to find NLTK models and that kind of stuff. And you can really go wild here. Another good thing.
So there's the space. Is it Spacey? Is that how you say it?
Yep.
OpenCV.
Yep. Yeah, Spacey's cool because this is just NLP. Hugging Face is everything, but you should check out Spacey if you want as well too. Um,
So on these sites, when we're checking out these sites, are we able to prompt it to design to generate a code for us? Is that what you're saying? Or
No, these are pre-trained pipelines, but you could ask your LLM to create code that used one of these pipelines, right?
so I
So
can
so
tell Claude
Spacey's
to
just yeah, I'm sorry, go ahead.
so I can just tell Claude to generate a code using Spacey or Hugging Face.
Well, Hugging Face is a bunch of different models. So you could find a model on Hugging Face and import it because they're, a lot of times they're in pickle files and stuff like that. So you could create code that could use a model from Hugging Face, but you can use Spacey has packages that you can build right in. So you could tell your LLM to create an NLP model for NLP off of Spacey, based on Spacey. And then you have to do the same thing like we've done with a bunch of other stuff. You have to install Spacey, so pip install or kind of route. But
That's the issue
uh
I've been running into with Claude, and once I place the code and run the code in Jupyter, it tells me UMAP not available. Please install PIP, and I'm like, I don't even know how to navigate, how to work around that anymore.
yep. Well, you could ask your LLM, but basically you have to in a cell. You could open a notebook and do like pip install, and it would do it.
Oh, do a pip install within the Jupyter notebook?
Yeah, just create a new notebook and then run pip install in one of the cells. You can
Ah.
also open a terminal prompt in Jupyter as well if you just want to run it right from a prompt, but you can just run it in a cell too.
Mm. Wow. Okay.
Yeah, that's a good question though.
Okay.
All right.
I hope I can figure it out because
If you can't, just post something in Discord and I'll be watching for it.
I have a question in regards to the capstone.
Yep.
I know it's a little bit off topic, but it is still the capstone.
Mhm.
There is a section where you, under documentation requirements, there is something about pre-phase markdown. What is a pre-phase markdown and a post-phase markdown?
Oh, the markdown is that's when you put the text in the Jupyter notebook. You can just put plain
Oh,
text.
so that's what you mean when you say,
Yeah.
okay. So you still are talking about the markdown within Jupyter. Okay.
Yeah.
It's the pre-phase and the post-phase that threw me off a little bit. I wasn't sure
Yeah.
if you're talking about the same markdown from Anacon from
Yeah.
the Jupyter notebook, or you're just calling something else post-phase, pre-phase markdown. I just needed clarification for
No, that's a great question. I'm glad you asked.
that. I wasn't sure. I didn't want to just assume that it's the same markdown.
Yep. I think that's a good call. I'm glad you're asking these questions.
Thank you.
Yeah, you're welcome. Okay. All right. So there's lots of stuff out there. You can NLP is fascinating. It really is, because it is like it transcends the purely numerical and logical to something that is less numerical and not and logical, but you can still you can still apply some numerical analysis to it. And this is how, right? And it's not perfect, but there are some good models out there, like Spacey is an awesome one. So play with that. There's a bunch of great stuff still that we haven't even touched on in Scikit. There's a lot of stuff in life science and medicine that is related to NLP. So they're doing things like NLP now for doctors, transcribed case notes and stuff like that. It used to be when I went and saw my doctor that they actually had a transcriptionist that sat with him.
Yeah, they have
Well,
a scribe usually with them. Yeah.
now he just has a clip-on microphone and AI does it. So he doesn't have a note taker anymore. And he's like, I don't know what to do. I don't have a note taker anymore. So it literally takes what they say during the visit and it transcribes it using AI, and then they process it and it all gets put into your medical record. It's pretty cool. A lot different in the old days. And especially with the amount of stuff like on the web and things like that that are text and things in emails, this is super important.
Yeah. That's sad though, because that means the scribes they've been laid off. They probably lost their jobs as well. However, usually the scribes are students in pre-med. So I don't know what they'll do now, but they'll be letting the scribes off. They're using AI to transcribe doctor's notes.
Yeah, it's pretty wild. It's a lot of things are changing. I mean, it's anymore when you talk to customer support, usually the first couple layers of it are all AI. So we're going to see where this is all going to go. But we don't have to worry about it because we're AI wranglers, right? We know how to run AI. We don't have to let AI run us.
Yeah, we know how to run it, but wish us luck. We're in the job market.
Yeah, well, but this is a thing that is I mean, this is a big differentiator, right? That if I see the tide changing, if you look at job postings and things like that, if you're able to insert into there, you have experience doing things with AI, and something like this, you have a conversation about it and show off some of your work. I think it puts you in a better spot, right? So. But this is all new. I think it's going to go to where someone's going to say we don't need that position. They're going to get rid of the person. They're going to realize, oh, we need an AI wrangler. We just don't need a manager to do this. Okay. All right. So I already posted this. This is assignment 6. This is the last assignment that is due before the capstone. And again, I'll take all assignments up till a week after our last course date, so 11th of September. And so basically, all this should be reusable for your capstone project. And then hopefully it's not a big lift at the end to get the rest of the requirements in the capstone done. It seems kind of daunting on the surface, but think about it this way. We've already done the whole machine learning pipeline, and now we just have to execute against it, right? So basically select the best performing approach. That's in your estimation. I look at methods. I look at how you're doing things. The numbers don't all have to tick and tie, but I get a sense by looking through your Jupyter notebooks about how well you're grokking things. And again, there's no right or wrong answer with respect to the capstone, just like there's no right or wrong answer with respect to the homework. I just want to make sure that you're headed in the right direction. So when you leave here and we're done with this course, that you're actually able to go out and do some of the stuff, right? That you can take a log file and you can use AI to help you generate some Python code where you can get results, right? That's really what I'm trying to accomplish here. And hopefully you're taking that away. Jose?
Just on the prior topic of the NLP libraries, are there any risks or concerns with using any of those libraries on sensitive data?
No, it's all running on your machine. It's much the same with Scikit. It's not like an API where you're going out and it's leaving the confines of your machine. If you put it in production, I would say that's a different conversation. But with respect to it running on your machine, there's really not. You know, again, if you're sharing it, you should be concerned about it. But it's not like so, and this is a really good question, and I want to emphasize this point. People think when you talk about AI that you're going out to Gemini or Claude or Chat GPT and you're pasting the company trade secrets in there and you're letting it rip. And then anybody else who knows how to use Chat GPT or anything else is going to be able to go and look at that information. And that's not what we're talking about. That's why I be careful what you tell people, because people that aren't as informed as you are will jump to conclusions, right? For instance, if you're using an LLM to write code, you don't give it the whole database. You could just give it the schema of the database and maybe a few synthetic records to get the pump primed. And then once you have the code generated by the LLM, when you bring that code back inside your environment and you're running in your Jupyter notebook on your machine, that's not connected to the LLM, right? So, but great question. And I do this, well, the LLMs don't take a file of a huge size. So what I do is I take the files and I cut them down so they're smaller in size. And that's what I use to feed to the LLM to get it to write the code for me. And then I put a bigger file into it, if that makes sense. Did that answer your question?
Yeah, so let's say if we were to do, like you said, you usually start with like a proof of concept using your LLM to create code. Once you get to that point and you said, work with DevOps to put it in production, it still wouldn't have any risk to using these libraries, because these libraries still run locally on whatever you have. So
Yep. As long as you're not calling an API. So for instance, there's some like Graphistry, PyGraphistry, for you to get a graph result with PyGraphistry. Unless you're running one of their servers internally, you're calling their API. So a case like that where you have to have like an API key and you're calling outside, you wouldn't want to send sensitive data to that necessarily. But for these things that we're talking about here, we're loading the Python libraries on our own machine and executing it, and that doesn't send any data out externally.
Steve,
Yep.
for the upcoming assignment, the assignment 6, are
Yep.
we still working with the same malware data set?
Yep. This is just the last little bit of analysis. So you implemented supervised and unsupervised, figure out what the best method is a single algorithm, is an ensemble method, and then that's what you'll use to complete the rest of the capstone. But it's basically a succession of going through the entire thing, use that same malware data set. But good question.
Thank you.
Yep. And then, of course, my favorite thing now is to do Streamlight Dashboard. This is a Streamlight Dashboard of the demo code that I did. And it's not pretty. I didn't spend a ton of time making it beautiful, but this is sort of the output you can get from that same kind of code. And again, this is a real real data set. But you can see, it does a topic modeling, it does a word cloud, command lines, which didn't show up in the Jupyter Notebook for some reason, but I got command lines here. Didn't troubleshoot that. So, shows you the composition of the topics. So lots of cool stuff here. And this is all stuff, again, you guys are probably smarter than me, but this is, all done with the LLM. Say, go make this for me. So I'm not an expert in Streamlit. I just really like it. But this is the kind of stuff that you can get out of there and play with, and hopefully take forward into your career, right? So this is the interactive dashboard is not interactive. I don't know why it says it is, but here's like detailed reports. You can export the results. Again, I showed you some of that stuff like threats and anomalies and those kinds of things. Those were those spreadsheets that I was showing you. So you can take this anywhere that you wanted to. So it's pretty cool.
Hey, Steve, quick question. Have you deployed any AI agents, with respect to the models that you have developed?
So yes, but it's funny because there's some stuff that it's just too easy, right? There's some stuff that it's like the biggest, but the biggest challenge is there's your models have to be really good and your agent parameters have to be really good if you're taking some kind of action. And this is still kind of I won't say it's a gray area, but it's a risky area. If you look at like the OWASP, top 10 for AI, they talk about agentic AI a little bit because, the issue is this is if your if your agent can take a privileged action. So let's say if I detect something, I'm going to put you in a timeout, like a VLAN that doesn't have access to the corporate network or the internet, put you in the parking lot kind of deal. That can have real consequences. And then the issue is not just if I take an action that impacts production. The issue is this, right? Is if somebody figures out how to, in an adversarial mechanism, right, abuse that AI and make it take privileged actions, right? Because if you have something that on the backside has like administrative privilege to be able to change network VLAN assignments or something like that, what if I figure out how to do that and I get that agent to take everything in the whole company and put it in a timeout, right? So there's pros and cons to that. I think there are some things that agentic AI is useful for, but I think we're early enough on in this that you should be prudent with what you ask your agentic AI to do. Maybe start with saying, I want it to highlight this particular thing, or take some kind of action that isn't prejudicial to production, but you need to kind of think that through.
So this is more like a reactive approach versus proactive, where we detect and then we apply those preventative controls along the line.
Yep. Yeah. So and that's a good question, because traditionally cybersecurity has been reactive, right? Something happens that's bad and
Right.
we take action. But what we're trying to do is accomplish a shift left by saying we have learned from all the things that go bad, and we are looking at that constantly. And when we see an indicator that might be getting ready to occur, we flag it, right? So we're taking action before something bad happens. And what we're doing is we're saying, oh, this is a configuration problem, or there's a weakness in our environment. We have indicators that something is not deployed correctly, those types of things. We used AI in our code pipeline at Google, and we had pre-submit checks that would go through, and everything that was going into production, it looked at because we were deploying into Kubernetes, it was infrastructure as code. So we made sure that was properly configured. that the code was written properly, that that had the proper sign offs. If you had only submitted a certain number of lines of code, somebody else had to sign off on it. There's tons of stuff in that pipeline, and it helped make sure that we did pushback. So those types of things are what we're talking about, right? Is you can't deploy something unless it meets the applicable patterns, right? We're looking for anti-patterns.
Got it. Thank you.
All right, cool. All right. That's all I got. So unless there's any other questions, I'll let you get on with your Thursday, and I will see you next Tuesday. Let me know if you have any questions in Discord, and we'll go from there.